A car has an initial velocity of 45 meters per second, so that's v0. It accelerates for 4.8 seconds, that's time. It covers 264 meters, so let's call that our final position. We're going to call our initial position because it's not specified, we'll just call it 0. So our final position is 264, and we need to find acceleration. So again, we start off with the second kinematics equation. And in this case, we won't be able to get rid of all the variables, or at least most of them, as we did in the previous problems. And that's why you always write this out to start. We're going to assume that x0 is equal to 0. However, we do have an initial velocity this time, and we have to solve for acceleration. So let's start the algebra. We'll put v0t on the other side by subtracting it from both sides, and that equals 1/2 at squared. Let's multiply this side by 2, so we have 2 times x minus v0t. That's a terrible t, there we go. And that is equal to at squared. We now have to divide through by t squared, and we'll put a on this side. So I have 2 times x minus v0t divided by t squared. Once again, if you get that far, you have shown your teacher you know what's going on with the equation and the physics, and all it's left to do now is substitute in the numbers. And when you do that, you put the numbers in. You can see this equation, the same one we derived here. You put in the numbers and you get 4.17 meters per second squared. This is the bulk of the work. That will get you the most credit for the problem. If you miss a number at the end, teachers typically do not take off a lot of points for that.